To day 2 of the Palm Conference program, so let's dive right in. We begin with a high-impact session today. The reference is The Voice. This session features key members from the Adamson system engineering team who will dive into the transformative impact of Adamson's core technologies on the audio industry. And the discussion will emphasize the standardization of knowledge to support engineers, enhance product use, and foster innovation.
Good morning, everyone. Thank you for coming. My name is Pieter from Hoogdalem. Like we were introduced, thank you for the introduction. I appreciate it. Thank you for coming here today. So what we want to do this morning is we want to tell you more about the principles that Adamson has been founded on. Because if you look at the history of our product lines from the early 80s, we are more than 40 years old. From the early 80s until now, it's a natural evolution of continuous improvements based on a few principles that we will tell you a little bit more about. And we will do that by illustrating and telling you more about our latest releases, product releases. So in the last few years, we've experienced rapid growth as a company. We've been expanding very rapidly after COVID. Everybody had a period of time, and I'm sure all of you can relate, things had to start up again, right? There were supply chain issues during COVID. Some people may have moved jobs. We had to find the right people in the right positions again. But in the meantime, we've never stopped during that whole period continuing the development and the research and development of our products. VGT was released in January 2024, so a little bit over a year ago. VGT is a flagship line array, which offers a technological package that we believe what we can offer right now is at the forefront of live sound and technology. And we will tell you a little bit more about that in a moment. My colleagues will expand on that. We're going to be releasing very soon, we're going to be announcing some new products that we're going to release. So around Infocom, early June, we will have some very exciting new product announcements that I am not allowed to tell you anything about today. But you can rest assured that this will be a continuation of building our own Adamson ecosystem. As you may or may not know, we make everything in-house in Canada ourselves. So that goes from the rubber handles from a speaker to the Kevlar cones of a driver. The amps, we just invested in a new SMT high-speed assembly line. We make our own amps, we populate our own PCB boards. Everything is being done in-house in Canada. This allows us to, in our research and development, to experiment with materials, with composites, etc., and therefore have more control, not only about, on our products and the technology, but also in the supply of, well, not being dependent so much on supply. We were already introduced, so before we continue and I hand over the mic to Lee Stevens, I want to say feel free at any moment to raise your hand, ask questions. We would like this to be an interactive event. We are here to answer any of your questions. We will also be available after the presentation. If you have any more questions, we will be happy to take those questions, right? One example of how we continue to expand is that we need more boots on the ground. We've seen a sizable increase in demand for our products. And one example of this is that our recent hire, Thaddeus Sundar, who has joined us a week ago, Sundar, right? Yeah. we're very happy with this, and this is not where it stops. Sundar will be based out of India, and he is here for you guys, right? And he will be visiting all of our end users. He's very reachable. If anybody wants to know more about our products, please reach out to Sundar. And that's not where it ends. We keep continuing our expanding our team in the APAC region, and especially for us, India is a very important market, and that's where we will keep investing in. So, without further ado, I'll hand over the word to Lee.
Thank you, Pieter. Hello, good morning, welcome. I'll just skip past these because we did all this. My name is Lee Stevens. I'm the sales director for Adamson in APAC. And over to my right there, we have the dashingly handsome Carlos Sallaberry, who's the head of applications for APAC as well. Also, we've got Kiran joining us as well from the Middle East perspective, just to add a bit of weight to what we do. So I think Adamson is one of the core technologies and what's been at the heart. We're an engineering company at the heart of it. We're not a sales company. We're not trying to sell as many loudspeakers on the planet as some of the others. At the heart of it, we're still an engineering company. And that drives us consistently forwards for 40 years. So Brock Adamson is an engineer at heart. He drives all of us to be engineers as well, and not to have the kind of how many boxes can we sell? How do we do this? Everything we do is designed to be class-leading kind of engineering products that meet the demands of the industry. So one of the core foundations that's always been with us from day one is the voice. One of Brock's mantles, one of his passions, I suppose, is how do you replicate the voice? Completely clear, undistorted, completely transparent. And if you can replicate the voice perfectly, then the rest is pretty easy, let's be honest. It's the voice which is the biggest challenge. Now, you ask any loudspeaker manufacturer within this building, they will all have the same issue, So I suppose what we're going to do is we're going to make this a bit engaging and kind of throw it back to people in the audience and, kind of get some kind of feedback from people. So does anyone know kind of the frequencies for the voice and kind of roughly, because obviously it varies from different size, height, weight, culture, in language, etc., etc. But does anyone know the kind of frequencies that the voice operates on, or kind of? There's my comedy sidekick.
Not, huh? No one. Anyone want to engage?
Nope. Any ideas? Okay. So the male voice, generally, I say generally, if you're me, mine's a lot more squeakier than Carlos's. That's just, I've got a silly, annoying English accent. So generally, it's 100 hertz to 8 kilohertz. What about female? Anyone else? Female voice? Nope. Okay. So the female voice is 200 to 8K as well, just slightly higher. Once again, some of the females I've met, probably, it's a bit dubious, but, And the last but no means least is children, which is roughly around 250 to 8K as well. So with all that in mind, that is at the heart of what we do. So if you can replicate that range and that response in every box, then that is a good place to start. So this all leads on to intelligibility. And like I say, trying to make sure that what we replicate is exactly in that frequency spectrum or bandwidth. Buttons. There we go. So when we look at intelligibility, the most important weightings generally found across the percentages is round about, that's the kind of, if you look at the Steinberg and French papers from 1947, that's basically what the benchmark is for intelligibility. So without going too much into STI and speech transmission, that's generally what you look at in the vocal range. So it's very geared around the 2K mark, and obviously it goes all the way down, but that's the kind of weighting that you kind of see. So with that in mind, and taking that as a bit of the basics, we work in when we do our predictions within the software, we work in something called Y weighting, which hopefully my laser will point at work over there. Y weighting is generally 2K to 8K. If we can predict 2K to 8K perfectly within a space, as I said, the rest is pretty easy. Now, obviously there's DBA, DBC, and flat as well, which other manufacturers use. A lot of other manufacturers choose one frequency and base it around that. A lot do, there's some options. But at the heart of everything we do is around the voice. So even our prediction software is around Y weighting. So if we have that, if we get that Y right, then the rest is pretty easy, as I said. That all kind of makes sense to everyone? Yeah, makes sense? Okay. Who's actually used the software here? Has anyone used AI or AI intelligence software or Blueprint, which was the older version?
Do we have any Adamson users in here? Has anyone used our boxes? Mixed on them? No? Yep. Okay.
Cool. Okay. Okay. So, as I say, the Y weighting is that which replicates the intelligibility of the hearing spectrum. So, with that in mind, as I say, everything we do is engineered towards that. So, there we go. So, our latest product that we've released is the VGT. This features a new patent pending style of compression driver. It's a 4-inch...
5-inch.
4 point something or other. Compression driver that actually has it's a floating pistonic driver. So it has actually no attachments to the basket, which means we can get a longer extrusion and deliver bigger SPL from something that people usually will struggle with because of natural designs of how a basket and how the driver actually interacts with the basket.
Yeah. So Brock Adamson, as he said, so the reference has always been the voice for us. It's been what drives the passion behind Adamson. And so Brock, over 40 years, has then come up with this new driver called the M140. So it's a true pistonic 4.5-inch, 5-inch mid-range compression driver. As you can see, there's a free edge design to it. There's no suspension to it. Basically, what it has is just a silicone suspension on 2 points, and this right here is sort of freestanding, right? It's just there, and that's what's moving constantly with the back and forth of it. So it's a 7-to-1 compression ratio phase plug with 160 dB sensitivity, with a range from about 300 hertz to about 4.5 kilohertz or so. And this is what's really in the heart of the VGT.
Yeah, so this goes back to that core, a lot of people, when they design a box, the crossover will generally sit within the vocal reproduction. So if we can design a driver that can sit solely within that vocal region, and we can obviously, it improves our clarity and speech transmission, etc. from that. So that's at the heart of the Vergence Group, which is our new line of products. At the moment, we currently have the VGT and the VGS. Has anyone seen it or been to the Stage Mix stand to have a look at the moment? Anyone heard about it? Look at the overwhelming. Okay, so the VGT is a dual 13, operates at 50 hertz to 20 kilohertz, has a 90-degree horizontal, 6 dB in the vertical, delivers a huge 151 dB, which, yeah, if you can find someone else that's as powerful in such a small box, then come and tell us. That'd be great. 84 kilos, and it's a powered box as well.
So yeah, it's a multi-mode cardioid design with two 13-inch drivers in the front and two 10 in the back. It's driven by a purpose-built five-channel amplifier, 12 kilowatts, designed specifically for this box. So within the software that actually runs it, AI, because of the DSP built in there, we're able to choose whether we want a cardioid pattern with the box or we want to use an Omni design.
I mean, this was basically driven around market feedback. So obviously there's brands out there that have cardioid boxes, which is great. Some of them are brilliant. And you know, when you tour around these kind of venues, when you go into these big arenas, or you know, you need the tools within your toolbox to be able to deliver in any environment. You know, and this is, I suppose, coming back to that engineering heart of ours, is like, we're not going to tell you what you need or what you think you need. We're going to give you the tools to give you the tools which you actually do need. It's a very different kind of approach. So the cardioid and the Omni, you know, switchable, is, you know, if you're into a very acoustically challenging arena or indoor or outdoor venue or something, you know, where you need to be aware of rear, you know, environmental things or just actual pattern control, then you turn the cardioid on, you know. There's a lot of acts and artists that still want the low-end warmth on stage. So sometimes you may want to turn it, you know, off and still have an Omni kind of feel to the box. You know, it's all very dependent. But we've given you the tools, and obviously this is just software-based, so you know, we can change that. We can add new patterns to this very easily. We're hypercardioid or, you know, any options that are available really to us. So it's giving you the tools. It's an engineering tool again. It's what we do. It's at the heart of what we do. So we're not limiting and telling you what to do.
You could see here, this here's the horizontal dispersion in Omni. You could see how wide that is all around. And in cardioid, you could see how we're able to cut in the back there.
And this has actually improved, I think, by all accounts, since just, you know, pure software refinement. So we've actually made it better. You know, so we're not confined by that. You know, it's a physical box. We're into software and we're into giving you the tools
proper
again.
DSP and everything else inside. So as I mentioned earlier, this is a custom and purpose-built amplifier for this specific box. 5-channel Class D DSP amplifier, 12 kilowatts, a 2 kilowatt PSU, very, very efficient. So within the software, we've got 1,024 FIR taps available per box, in order to be able to refine and create the perfect sound for you. Of course, all of that combined with, you know, as we build our line arrays, we're able to create perfect optimization.
So one of the biggest, obviously, once again, it's another thing that, you know, some people use this or use against powered boxes is, you know, what happens if I lose one box? You know, if I lose the first box on a chain of my powered array, what's the next step? How do I... Once again, we've taken all that on board. It's feedback from dealing with some of the biggest production companies in the world to design a product that will cause, yeah, the risk factor for you guys on the floor is How do we lower it? How do we make sure that if you lose one box, it's only one box? It's not a group of 3 or a group of 4 or whatever it may be. The challenges you have when you have an amplified system, or when you have another kind of powered box where it's all daisy chained. So on board we have 3 ways of audio redundancy. So we use primary and secondary A/V/B Milan, and we also use analog. So we have 3 fallovers for audio redundancy. The other part of that is power as well. So there's full redundancy on that. Every port that we have is links through to the next box below. So even if you do lose one box, you literally just lose one box. You don't have to, you don't lose the top half of your array or whatever it may be. Everything just passes through to the next box and you carry on. Obviously in the software, you get that feedback from the software as well to tell you, what's going on with that box, be it a power drop, network drop, or whatever it may be. So, where am I at? Where are we at?
You got ahead of yourself.
I know, I've got very... I think Carlos kind of mentioned as well, like the amplifiers have all been built in-house by us. We don't use any third parties or OEMs. Everything we do is in-house. So we've custom built these amplifiers to suit the design of the box. So what that means for us is we've created an extremely efficient, power-efficient loudspeaker and amplifier platform. So with the VGT, for instance, maximum draw on a VGT is 151 dB, is 3.6 amps per box on a 12 kilowatt amplifier. So what that means is on a 16 amp Trucon, clicker, there we go. What that means on a you can actually run 18 VGT off one 3-phase, 32 amp 3-phase power distro. So what does that mean for the engineers on the floor? You're saving money on trucks. Let's cut the rubbish out of the way of it. You're saving money on truck space, which is one of the most expensive commodities on the planet now, is fuel, people, trucks, etc. So if we can save you money on that, we're trying to help you engineer a better result for the brand and for your shows. So for instance here, you can see 18 E15s. It's a standard kind of configuration for us. That's two rack spaces. For one 18 VGT, you've got 4 RU of rack space. And that gives you, that's your network, that's power, that's absolutely everything in 4 RU.
Fully redundant is there as well. Fully redundant audio happening here as well as the analog backup. So we've got a feed coming in either through AV/B, through a primary and secondary port, or through fiber. There's a couple of switches in the rear, which then split or actually combine the signals into a single cable. And off of a single Cat5, we're then running a redundant signal of AV/B into the boxes. Should either one of those AV/B fails, it automatically just switches over to analog. It's quite quick and quite seamless as well.
I don't even remember putting that slide in. Anyway, okay. So this kind of amplifier platform also goes across the entire range. So the VGS, which is the first subwoofer option that we have for the VG family, is a 6,000 kilowatt amplifier. But it means, because we've designed the amplifier to suit, it means you can get 24 VGS off one power distro. Again, which if you compare that to amp racks with our previous, with E119s or E219s, this is, you've saved yourself 2 or 3 racks straight away.
So has anyone been by the booth to take a look at the VGT yet? We want to let you know that there is a demo system currently in India. It's available to go out and do some shows. We want to get the system out in front of engineers. We want to get your feedback. We want to take that feedback back to our engineers at Adamson, because everything is driven by you guys. You know, that's the most important thing. We want engineers to talk to us about our product, to give us feedback about our product. Ultimately, that's what drives the passion with what we do, and so it's important.
So what I would want to add is that when we announced the release of the VGT a little over a year ago, we spent a lot of time working with a few of our key partners in prototyping, testing, getting feedback from them before we released it to the market. That included Claire Global, DV2, which is a longtime partner and ally of Adamson based out of France in Europe, and PA Shop, which is a regional or Canadian company around the corner from us, right? And we took that feedback, presented the box to front of house engineers, held demos, got the feedback, and made, you know, adjustments to ensure that there was a market credibility before we would release it. So currently, VGT is out on tour with Imagine Dragons. It's out on tour with Linkin Park. They just finished their American leg of their tour and taking the system now to Europe. We've rolled out the system by now in many European countries. We're shipping it throughout the States. We've released into, well, we've got a first rig here in India now. We've shipped a rig to China. A number of rigs already are in Japan. And we expect this to continue in over the next few years, obviously. That's the whole goal of our business.
Cool. So at the heart of everything, as I said, is software. That's a big part of what we do now. Array Intelligence at the moment is our software that we use to design. We use to simulate acoustic models. There's a lot to kind of cover in Array Intelligence, but once again, it's all driven by the market. It's based upon the feedback we receive from our engineers, telling us what's right and what's wrong. You know, we've got to learn, we have to grow, we have to, you know, evolve, and we're not, as I said, we're an engineering company. You tell us where we're going wrong, and that's how we move. So Array Intelligence, we started off with Shooter many years ago, and then we moved into Blueprint, and then Blueprint now has evolved into Array Intelligence. So what Array Intelligence is, as I said, is it's a complete control package. Mouse will stop working. There we go. So it's a complete two-way control package using AES-70. So we can monitor, we can push information backwards and forwards between boxes, individual boxes, entire systems, etc., etc. There's things like inclometers built into all the boxes. There's two-way communication. We monitor absolutely every part of the box and its components. So AVB streams, there's individual drivers, we monitor, everything is actively monitored on that box, and it's designed to give you the feedback as an engineer to go, oh yeah, I'm getting network drops on this, or whatever it may be, and you can see that right in front of you. Skipped ahead. Here we go. It's a very simple layout, it's very natural, it feels very natural, the flow goes from left to right, you design your system in Blueprint, you build your I/O, then you do your control, and then you do your monitoring. It's a very, very basic layout and format, very easy to understand. Wow. So, where are we at now? Hello. There we go. So on board, as we said, we've got 1024 FIR filters on every box. Now, if we gave you that, that would be very dangerous. So we kind of limit that to about 25 per box, which is still a lot. And that's per box. So if you've got an array of 10 boxes, you've got 250 FIRs to play with on board that. So what I'm going to do is I'm going to jump through to some bits here that probably is better to demonstrate. So one of the key tools that we've added into the powered boxes and powered family with the CS and VG is our array optimization. So is anyone familiar with some other manufacturer's array, whatever? There's a German company that does it for a long time. French does it not so well. Well, not so publicly well anyway. So array optimization is our version. Now, if you take into consideration what we've got on every box, if you go, we've got 1,024 FIRs to play with on every single box. It gives us some real finite control, which nobody else can really offer within the market. So here you can see a kind of system. We've just done a quick 2D model to kind of demonstrate. As you can see, that's our optimal kind of line that we aim for across the space. Here we go. So what we have then is optimization. So optimization, we can get down really granular. So we can stick virtual mics in, and then we can actually control each plane, as you can see there with the yellow, the orange in the bottom right corner, is basically we can then manipulate the frequency sets to suit and to kind of flatten off or hit a target curve you specify. This can be the full broadband spectrum, or the exciting bit is we can flip to frequency constraint, and that means you can pick a kind of frequency that's giving you problems within the room. So you can select a group of frequencies and just optimize them. And the best thing about this, it adds no latency. Now, if you know some of the other manufacturers, as soon as you turn on array, whatever, you gain latency instantly, straight away. It's a big factor. With this, there's no additional latency at all. So it's the same, and the reason is obviously we have the latency at the beginning, but it's still not as long because the advanced DSPs that we have implemented within the box.
Yep. So something about the optimization that Lee was talking about, I think it's important also to understand the frequency side of things. So the regular frequency constraint is basically 100 hertz to 20 kilohertz, right, when we are doing the optimization. But like Lee said, you could choose the frequencies that you actually want to work with in the optimization. So, for example, what the algorithm actually does is takes care of the low-mid extension and the low-mid build-up that we have in a typical line array, but also takes care of the HF loss right at the end of the entire venue. If we do not have any one of those frequency issues, we could actually choose anything outside of the 100. So if, for example, if we have no issues with one particular room, but we have a lot of issues on the high end, we could actually choose anything 2K, 3K, 4K upwards up to 20K, right? So it's the frequency constraint here. We don't have a slide that shows the green, do we? Yeah. So choosing the frequencies actually also helps build up the optimization for that. What you could see here in this slide is basically the top portion of the slide shows you what is happening regularly with the PA, and the bottom is actually showing you what happens post the optimization. And you could see this while initially doing your design before you actually export all this information to the boxes itself. Right.
So what you can see there is the obviously in that low mid-range, probably about 400, I would guess, by looking at that. There's a variance on each box. So each one of those orange lines is each box. What we're doing there is adjusting the variance and trying to get the variance as close as we can physically get for each box by using FIRs and everything. So obviously here, for instance, on this, we've dropped it from 9 dB to 6 dB, so which is massive in that kind of terms. So hang on, let me see. The same with the HF here, as you can see as well. So without optimizations, obviously the top, there's a variance of 12 dB in all the boxes. We can manipulate this down to a 5 dB kind of window, which is what you're trying to do is, obviously get that every audience member has the same experience. And because it's individually, we can do this very, very easily within each box. So here you can see with optimization off, 400 and 8K. I don't know if you can see that, but there you go, that's optimization off. And once we've applied optimization, you can see, especially in the far field, kind of the improvements we can make very, very simply by just turning on the optimization. So how do we do that? Basically, this is what the very stripped back version of the each box looks like. Over here, you've got the inputs. In the green, in the grey, you've got the bits where we do the hard work for you. That's all the internal processing. That's the how we make the box sound like it does. And obviously on the right, we have the amplifier. Now, anything that's green is, let's call that the artistic component of the box. So that's all down to you. That's your personal choice. So however you want to color the system to suit, that's what you got. Where optimization sits, it sits roughly in using the FIRs on board, but sits within the kind of hardware side that we've done. So you can't take it beyond its capabilities and what the boxes are actually capable of. So. Any kind of questions or any kind of feedback or? I'm hiding behind a lectern here. I hate doing that. Let me go over here. Okay, so with that, if there's no questions kind of thing, next part of what we do, because we have individual box control, it means we can take our sub-array designs to the next level as well. Same DSP on board. You want to talk? You love this. Who wants to do this? Oh, great. Look at the hands up. So this is basically demonstrating kind of the kind of interference and basically the theories of kind of room nodes and comb filtering and interference between two different wavelengths. This kind of becomes the foundation of sub-array, and what you're trying to do is reduce the cancellation between box to box at various low frequencies. I'm going to go here, aren't we? So some of the algorithms we take in part into consideration within the box. Obviously, we take basically the highest operating frequency, and we're trying to use all these kind of the standard kind of algorithms and of different wavelengths to give you the best results possible. So usually this is taken from our training. So usually it's a lot more in depth, and I'm going to rattle over it very quickly because I know we're very thingy for time. Okay. But taking that all into consideration, what we've got is when you do your subs, you can do full optimization. And you can choose the kind of width, the opening width, the design, however you want to do, and we can apply this in real time whenever you want. So, there's no uploads or anything else. It's, if you've got environmental constraints to take into consideration, you can go, I need to turn on optimization at 10 o'clock because the local neighbors, and we can do this live within the system. So.
And I think with the subwoofer calculator that we have two of the major options that give engineers the option of actually having the calculation done in an omni or in an ellipsoidal, which is basically much wider in width, right? So you could actually choose that, and you could actually see those results pushing all that information to the boxes because of the DSP, right? So we could do multiple optimization tryouts, designs, and then see what actually works best for that venue. You could do that live. Once the information is pushed on the boxes, you could actually switch on and off and actually hear it for yourself live, right? So that gives a lot of the engineers the options to actually, like Lee said, taper down, not disturbing neighbors on the left, right, and those options are actually very, very easily available. And because the DSP now lives in the box, it just makes it easier for all of us to have those options available for us to make sure that we've got a complete optimized system, right? Whether it's the optimization on the array or on the subwoofer side of things.
And once again, I mean, that's driven by the engineering part again, which we keep going back to, is engineering's at the heart of what we do, you know. This gives you the tools. If you've got, like I say, a certain act that wants that low-end feel on stage, which is we're in a strange place now where we've got older generation acts that want that low end on the stage still, and the younger generation don't want that on stage. So how do you deal with that in a live situation? Well, we're not telling you that every act has to use the same subwoofer configuration. You can actually go in and go, the headliner wants the low end, we'll just turn it off for this, where we're not telling you, you use the tools that we give you to deliver the best output of the system. Go on, Kiran.
Yeah. So, like I mentioned before, we've got the two options, which is the omni or the ellipsoidal. We also, like Lee mentioned before, you could see the opening angle. You can actually choose the opening angle of how wide or how narrow you actually want your subwoofers to act, right? Very, very important. You can also choose the maximum on-axis SPL loss that you actually want to have or not have, right? Basically what that does is those options for us just make it easier in terms of subwoofer spacing, distancing. We do not need to calculate anything else apart from this stuff because we've basically made the software to do that for you, right? I'm pretty sure everyone has used subwoofer calculators in the past with whatever system that we use. We have taken all that information, clubbed it together to make, what makes sense for everybody. I don't think it's probably right to say it only makes sense for us as Adamson, but I think, like Lee also mentioned, we are an engineering company, so it needs to make sense for everybody using it, regardless of the brand, regardless of the subs you're using or the tops you're using, right? So the DSP is, the most powerful over here. Yeah, Lee?
There you go. Just some pretty pictures to demonstrate. So obviously that's, when we do the calculation, it takes everything into consideration. Spacing, you can dictate the spacing, it can give you independent delay times, etc., for each box. So this is, I suppose this is our target curve. This is what Y looks like with the systems. This is what we try to design to. And this comes back to that whole why we're predicting why a multi-band frequency as opposed to a single band frequency, because I could take 8K and that look brilliant, you know, and then I can present the end user, look at this amazing, look at this amazing acoustic map that we've delivered in 8K. But if you move it to 8.1 or 7.9, it's going to look terrible. Or, you know, let's say 4K, you know, an octave down, it could look absolutely terrible. But, you know, so that's why we look at it, and that's why we kind of look at these curves, and that's why we predict into it, because you can't, it may look great on a single frequency, but any variation on that frequency, any room nodes that are unpredictable, anything else, we're trying to predict in a kind of a wider spectrum to get the best and optimum result.
Also, one thing I'd like to add is if you guys are a bit confused about 6 dB, it's basically when we design in the Y weighting that we use because of the vocal intelligibility of the system, we would like to ensure whether it's Y-weighted or a single frequency, we have a very, very even distribution from front to back in the 6 dB mark. That basically helps us deploy our systems and getting it sounding as close to perfect as possible, right? So anything more than 6 dB for us, front to back, is probably not a very, very optimal system. And I am talking pre-optimization as well, right? If we are well within the 6 dB range from the front to the back of the entire venue, then everything else that needs to be done on the system is pure and simple. And you know, so that's the kind of benchmark we always like to keep in Adamson, having that 6 dB range from the front to back. Whether it's Y-weighted, whether it's C-weighted, A-weighted, and just also to add the fact on the software bit, we do design in Y-weighted, but yes, we also understand that a lot of engineers like to see the A weighting. Some of them like to see the C or the flat weighting for the subwoofers. We have those options on drop downs as well. So it's not that we only do Y weighting and then we hand it over, you know, to the end client or the end user. There is also options of the A weighting, C weighting, and flat weighting when we are actually designing the venue. Yeah.
Okay. Because we've run out of time. Look at that. We even got a nice slide. Can I have any questions from anyone regarding anything that we've discussed, or any other questions they may have, or feel free to grab us afterwards if you want, or come to the Stage Mix and Sonotone booth over in Hall 2. We're happy to discuss anything, take you through some of the software, show you some of the insights.
Hall 6.
Hall 6.
Hall 6. Sorry, we are in Hall 6 at Sonotone and Stage Mix. Yes.
Yes. Sorry.
But yeah, like Lee said, please feel free to come down and meet us at the booth. You will see the VGT. You will see the CS rack and how we do all the distribution stuff there. It'll be easier to actually show you guys the box itself, how stuff works in the box. And yes, Carlos and I are easily available to show you guys the software once you guys are there. Carlos?
Yeah, if when you guys come down to the booth, I'm happy to do a live presentation of the software as well, hooked up to the box so you guys can get a better understanding of how it really works. This was just a very brief overview of the technology that we've developed with the software and how it integrates directly with our boxes. So please come down to the booth. Happy to explain anything, answer any questions, and that's it. Thank you so much for having us.
Ladies and gentlemen, kind attention. The session Unlocking AV
They're kicking us off now.
What I also would like to point out in closing is that there is an interview published in the Palm Expo magazine that's available for free around this whole area. Do check it out. You will hear straight out of the mouth of Brock Adamson, founder and president of our company, the principles that he works upon, and the future of the company as he envisions it, specifically targeted at the APAC region. So thank you so much for your attention. Thank you for coming.
Thank you, everyone. Thank you.